Hello everyone, Namaskar. My name is Gagan Kumar. Welcome to my channel Maths Guidance. So friends, we have completed chapter 1, that is number system, and now we are going to start chapter 2, that is polynomials. And I hope that the journey of chapter 1 is very nice and you have understood all the things in chapter 1, all the concepts. And I have done lots of problems in that chapter also. I have covered all the portions of the chapter, so nothing to worry about. If you go into my lectures, all the 10 lectures, then that is sufficient for you, no doubt. So now let's move on to chapter 2, that is polynomials. Let me tell you that the things which we are going to study in this chapter are first of all, we will go through some terminologies like what is a variable, what is a constant, and what is an algebraic expression, and coefficients also. Then we will see that polynomials, what are the polynomials, what are the types of polynomials, degrees of polynomials, number of terms, like those things. Then zeros of a polynomial. Then we will see the factor theorem, remainder theorem, and factorization, methods of factorization. So this is a very interesting chapter, and students like this chapter very much. Very interesting chapter. So we will cover it one by one, and let us start now today lecture 1, and we will move on slowly, and I hope you are enjoying my videos. Thank you very much. So friends, let's start the chapter polynomials. And the first terminologies which we are going to understand are constants and variables. So what are the constants and what are the variables? As all of you know that the constants, we say like this, that a symbol having a fixed numerical value, a symbol having a fixed numerical value is called a constant. A symbol having a fixed numerical value is called a constant. Fixed numerical value, any symbol having a fixed numerical value is called a constant. So it's called a constant. So like you can say that if you write 2, if you write 10, if you write -15, so all these are called constants. Its value doesn't change anytime. It doesn't change, its value doesn't change, so these are called constants. Now variables, what are the variables? Its value may change. Okay, the definition will be like this, that a symbol which may have different values is called a variable. A symbol which may have different values, or value, it's called a variable. Means its value changes all the time. Like if we write that area of a circle, let's understand this with an example. Area of a circle is equal to pi r square, or we can write that A is equal to pi r square. Okay, so here pi is constant, this one is constant, we know its value, but this r, its value may change time to time, so this one is called variable. And when this will change, so this will also change, its value will also change, so this is also variable. So with example, we have understood that this pi is constant and this r and a are variables. So these variables, its value may differ time to time, that is called a variable, and the symbol having a fixed numerical value is called a constant. So now constants and variables, these two terms we have understood. Now let us understand what is an algebraic expression. Although we know these things, but let us revise. expression, because if you understand this term then the chapter will be easier. So what is an algebraic expression? This is actually a combination of constants and variables. When the combination of constants and variables are added or multiplied or used with any mathematical operations, then that expression is called an algebraic expression. So the definition will be like this: a combination of constants and variables. A combination of constants and variables. Constants and variables. A combination of constants and variables connected by mathematical operations. Mathematical operations like plus, like minus, like multiplication, like division, okay, is called an algebraic expression. Is called an algebraic expression. Okay, so you can easily write an algebraic expression. Let's try. You can write like this, that 15x plus 7. This is an algebraic expression. Okay, this is an algebraic expression. You can write many terms also. This algebraic expression is having two terms. This is one term, this is one term, so it is having two terms. You can understand it from here. Now you can write like this: 4x square plus 5x plus 17. So this is also an algebraic expression. Having three terms, 1, 2, 3, having three terms. Okay, so algebraic expression and terms you have understood from here. A combination of constants and variables. See, this is constant and this is variable. This is a combination and having mathematical operations. A combination of constants and variables connected by mathematical operations like plus, minus, multiplication and division is called an algebraic expression. We have understood with the examples and terms of algebraic expression. So here two terms and here three terms. Okay, let's move forward. Now let us understand what are the polynomials. So its definition will be like this: polynomials, an algebraic expression in which the variables involved have only non-negative integral powers or whole numbers in powers, is called a polynomial. So we will understand this one: non-negative integral powers or whole numbers in powers, both are same things. So we will understand this. Let us suppose we are writing a polynomial 10x cube minus 5x square plus 7x plus 19. So here you can see that the variables, what is in the definition, in which the variables involved have only these powers. Variables, we have variables x here. This is a polynomial in one variable. This is an example of polynomial in one variable. And what is that one variable? X. Polynomial in one variable x. This is an example. And that variable is having the power here 3, here 2, here 1. Okay. So the powers are 3, 2, 1. All of these powers are non-negative integral powers, or you can say that all of these numbers are whole numbers. So as per the definition, we should have non-negative integral powers or whole numbers in the powers of variables, then and only then it is called a polynomial. So let us see another example. In variable x we have seen, let us see in y. So 15 y to the power 4 minus 10 y to the power cube plus 5 y square minus 17 y plus 25. This example will be polynomial in one variable y, polynomial in one variable, and that variable is y, one variable y. Now you can check the powers of the variables. The powers are 4, 3, 2, 1. Okay. Here also you can say that y to the power 0. So 0 you can also write. So all these powers are whole numbers. So this will be an example of polynomials. Okay. Now you can write one example of having two variables. How? Like this. Like 15x square y plus 9xy plus 10. So this expression, this polynomial is having two variables. Polynomial having two variables. And what are the variables? The variables are x and y, having two variables x and y. Now you can check the power of the variables. So here the power is 2 and 1. Here the power is 1 and 1. So all the powers are whole numbers or non-negative integers. Whole numbers or non-integral, which we have written here, non-negative integral. So either whole numbers or non-negative integrals. So this is an example of polynomials. Now let us see one different thing. Suppose we write x plus 1 by x. Will this be a polynomial? Let us check. This you can write x plus x to the power minus 1 for 1 by x to the power minus 1. Now you see the variables. This is if this will be a polynomial, then this will be of variable x. One variable x, variable is x. Let us check the powers of variable. Powers, okay. So the powers will be here 1 and here minus 1. So this minus 1 is not a whole number. Okay. It is not a whole number. So this expression will not be a polynomial. This will be an expression, but it is not a polynomial. Will not be a polynomial. Okay. Let us understand from one more example. Very easy example. Suppose you write like this: y square plus y to the power 3 by 2. So this will be an expression with variable y. But is this a polynomial? So let us check the powers. Powers are here 2 and here 3 by 2. So this 3 by 2 doesn't fulfill the criteria. It is not a whole number. So this will not be a polynomial. This expression will not be a polynomial. Okay. I think this is clear now. So now move forwards. Now let us come to coefficients. What are the coefficients? So first let us write a polynomial. Suppose 5x cube plus 2x square plus 17x. Okay. This is a polynomial having one variable x. So each terms, this polynomial is having three terms. three terms. Since you all know the terms of a polynomial, this polynomial is having three terms, 1 2 3, three terms. So each terms of a polynomial have a coefficient. Each terms have a coefficient. And what is that coefficient? So in the first term, 5 is the coefficient. 5 is the coefficient of x cube. 5 is the coefficient of x cube. Okay. Now 2 is the coefficient of x square. 2 is the coefficient of x square. Now 17 is the coefficient of x. 17 is the coefficient of x. So like this is called the coefficients. Let us understand from one more example. Okay, one more example. Let us suppose minus of x power 4 plus 15 x power cube plus 7x square plus 9x minus 17. So this is a polynomial having variable x, only one variable x. So what will be the coefficients? Here minus 1 will be the coefficient of x to the power 4. Minus 1 is the coefficient of x to the power 4. Okay. Now 15 is the coefficient of x to the power cube. 7 is the coefficient of x square. 9 is the coefficient of x. Okay. So like this. And if you can see, minus 17 is the coefficient of x to the power 0, basically, because x to the power 0 is equal to 1. So you can write like this. Okay. So coefficients, these are called the coefficients, the numerical values with the variables. So 5, here 5 is the coefficient of x cube, 2 is the coefficient of x square, and 17 is the coefficient of x. Okay. There is one more polynomial, we called it constant polynomial. So what is this constant polynomial? Suppose we write 5, or we write 2, or anything, we write minus 17. So this is also a polynomial. These are called examples of constant polynomials. These are the examples of constant polynomials. Okay. So this is a term called constant polynomial. These are the examples of constant polynomials. Now one constant polynomial is 0. 0 is called the zero polynomial. Okay. Now let us understand what is the degree of a polynomial. Degree of a polynomial. So let us write one polynomial. Let us write 2y square minus 3y2y plus 5. This is a polynomial in y, variable y. Okay, this is a polynomial variable y. And what will be degree? The degree is the highest power. It is the highest power of the variable. So here, what is the highest power? Highest power is 2. This one is 2. This one is 1. So this will be a polynomial in variable y having degree 2. The highest power is called the degree of a polynomial. How do we write it? Highest power is called the degree of a polynomial. Okay, this is in one variable. We will see degree of a polynomial in two variable also. Okay, now let us understand what is the degree of a polynomial in two or more variables. When the variables are more than 2 or 2, then what will be the degree? Okay, let's see. This is a polynomial in two variables, one is x and one is y. So you can say that polynomial with two variables, and the variables are x and y, with two variables x and y. If you have been asked the terms of the polynomial, so how many terms are there? 1, 2, 3, 4, 5. So 5 terms are 5. Now what is the degree? So in this case we take the highest power of some of the variables. Okay, so let us see, in the first term the power is 3, and here x and y, the sum of the powers of x and y, that will be 2 plus 2, that is equal to 4. Okay, sum of the powers, here the sum of the powers will be 1 plus 1, that is equal to 2. Here it is only 1 and here it is 0. Okay, so the sum of the powers, highest sum of the powers, okay, highest sum of the powers in one term, that is here 4. So we will say that degree is 4. Degree is 4 in this polynomial. So in case of polynomials in more than one variables, the sum of the powers of the variables in each term is taken, sum of the powers of the variables in each term. This is important, in each term is taken. Okay, and the highest sum is called the degree, is taken, and the highest sum is called the degree of the polynomial. Highest sum is called the degree of the polynomial. So we will check each and every term. Okay, we will check each and every term of the polynomial, and in which term we get the highest sum of the powers, then that will be the degree of the polynomial. Let us take another example, so this will give a clear view. Let us take another example. 4x square y cube plus 5xy square plus 9 plus 10 x to the power 4. This is also a polynomial with two variables, x and y. How many terms are there? Suppose we have to write the terms, then 1, 2, 3, 4. Now in each term we will check the sum of the powers of the variables. So in first term we have power of x is 2 and power of y is 3, so it will come out 5. In the second term 1 plus 2, it will come out 3. Third term it is 0, and fourth term it is 4. So the highest sum is 5, and that will be the degree. Degree of the polynomial is 5. Degree of the polynomial is 5. So this is the definition of degree of a polynomial, two or more variables. Suppose we have been given 3 variables, then in each term we will check the sum of the powers of all the 3 variables. Okay, suppose x, y, z, then all the powers of xyz we will add and check what it comes out, and the highest sum will be the degree of the polynomial. So I hope this is also clear. Okay, now let's move on. In the first lecture we have understood what are the constants, what are the variables, and what is an algebraic expression. Also we understood what is a polynomial and what are the coefficients and degrees of polynomials in one variable or more than one variable. And similarly we understood what are the number of terms in a polynomial. So all these things, these are the basics of this chapter. If this is clear, then further on it will be very easy for us. So these are the basic bones of the chapter, and we have understood it very clearly with lots of examples. So this is the end of lecture 1. From the next lecture we will see more things to come. Okay, and I hope you like this video. Please do like, share and subscribe. Thank you very much.